Hi, this is Mrs. Clark, and this is my video on angles formed by parallel lines. So we went over the notice and wonder activity already and kind of explored the different angles that show up when we have parallel lines. So today we're going to take some notes on different angle pairs that we can find and how the angles in those pairs relate to each other. So you may need some highlighters for maybe 4 different colors if you like to highlight. We're going to go through each vocabulary term, write down a description of it, talk about the measurement of the angles, look at them in a diagram, and do an example for each one. Alright, so first, if we're looking at this diagram, when we have 2 parallel lines and then we have a transversal coming through, it creates 8 angles. There are 4 angles up here and 4 angles down here. But the first pair that we want to talk about are alternate interior angles. So I'm going to highlight that first, just so that the name sticks out a little bit more on your notes page when you come back to look for it. So alternate, if we think about the root of both of those words, alternate and interior. Alternate talks about going back and forth, one then the other, one then the other. Interior talks about the inside. So both of those words relate to this diagram. The first term that I want to write down is this line that comes through the 2 parallel lines is called the transversal. So we know trans, like transport, transportation, means to go from one to another. So it goes through the parallel lines from one line to the other, kind of cutting it into 4 angles here and 4 angles here. So I'm going to put in a little note here. Actually, maybe I'll write it up here. Transversal. It's a tight squeeze here with that word. And that word references this one line that's kind of cutting through. So I'm going to draw an arrow to this. I chose to do that in color instead of in pencil so that it would stick out a little bit more. If you want to highlight the transversal, you can, just to kind of make it pop a little bit more. And so when we're talking about alternating the transversal, that means, if you notice, both of these angles, there's one on one side, one on the other, one on one side, one on the other. So alternating means one of the angles will be on this side of the transversal, the other angle will be on this side of the transversal. So if it's an angle pair, we're looking at 2 angles together. When I look at the word interior, that talks about between the 2 parallel lines, so in here. So notice I'm not including the angle that's there, 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 or there, because those aren't between the parallel lines. So of these 4 angles, there's a pair of them that are alternate interior one direction, and then there's a pair that are alternate interior the other direction. So if I look at angle 1, that is on the left side of the transversal. So the other one, in order to be alternate, has to be on the other side of the transversal. So the ones I have to choose from are 2 and 4. I'm not going to choose 2 because that would make a linear pair, and that's not special. That's not something different that we don't already know. So 1 and 4 are what we consider to be alternate interior angles. And that's for 2 reasons. We said the first, because they are on different sides of the transversal, and then the second, because they're both in between the parallel lines. So the location of alternate interior, the interior means that they are between or inside the parallel lines. And then this part talks about the alternate, meaning that they are on opposite sides of the transversal. So when both of those things are happening, we call them alternate interior angles. Notice this is an obtuse angle, this one's also an obtuse angle. When we did the notice and wonder activity, these were both on 120-degree angles. So their measurement is congruent. They are the same measure. So congruent, which means equal. So if I have a pair of alternate interior angles, I know they're the same. If I tell you this one is 110, this one's also 110. If I tell you this one's 93, that one's also 93. It also works for the other 2 angles that we have here, this acute pair angle 2 and angle 3. Those are also alternate interior angles, a different pair of alternate interior angles, different size angles. These are both acute angles, but they're also equal. So this statement down here is for us to use here the highlighted pairs of angles that we have. Angle 1 and angle 4 are alternate interior angles. So we have this little equal sign with a squiggly. That's the sign for congruent. So here we would say angle 1 is congruent to angle 4 because they're both alternate interior angles. Then we also have angle 2 is congruent to angle 3. So this shows how the two angles are related to each other in symbol notation, and this shows how they're related to each other just in words. So what does that mean if I look at an example like this? If I have an example of two parallel lines, this transversal cutting through, 8x minus 19 is this angle, and 6x plus 11 is this angle. And those two angles are an example of what we're just talking about, a pair of alternate interior angles. We have this side of the transversal and this side of the transversal, so they're alternating. And then we have both of them are between the parallel lines, so that makes them interior. So we know that those two are equal to each other. So if I wanted to find the value of x here, I could make an equation, 6x plus 11 equals 8x minus 19. I can solve this for x. Once I know x, I can put x back in here, and I will find the measure of both of those angles, which should both be the same if I did it correctly. Alright, so if I'm looking at this equation, we know our solving methods here, so we're going to bring our x's together. We're going to minus 6 on both sides. I'm going to go through this part real quick because we know this part already. I'll have 11 equals 2x minus 19. Then I'm going to add 19 on both sides. So 30 equals 2x. I'm going to divide by 2. And x equals 15. If I want to know what this angle is, I'll do 8 times 15 minus 19. And so 8 times 15, pull up my calculator. 8 times 15 is 120. Minus 19 is 101. So this angle is 101. I can do the same thing on this one. 6 times 15 plus 11. 6 times 15 is 90. Plus 11, which is also 101. So both angles are the same. So that's good, because they were supposed to be the same. If it asked me to find the angles, that's what I would do, just like always. Substitute your x back in and find the measure of your angle. Alright, so the next pair that we're going to look at is called alternate exterior angles. So let me highlight this title. Very similar to the last one, except for the word exterior. So if we're looking at the word exterior, that means instead of between the parallel lines, they're either above or below the parallel lines. So in the description here, we're going to write above. Oh, I didn't leave enough room here. Slash below. And then write outside the parallel lines. But again, they are on opposite sides of the transversal because they're still called alternate. And they're both going to be either acute angles or obtuse angles that are going to be equal, so their measurement is still congruent. So some of the angle pairs will be angles that are equal. Some may have a different relationship. You have to know what kind they are so that you know how they're related to each other. So if I'm looking at the example, or the picture, this time angle 1 is an exterior angle because it's above the parallel line. On the left side, it'll go with angle 4, which is below the parallel line on this side, but on the other side of the transversal. So angle 1 is congruent to angle 4. And 2 is above the parallel line here, will be the same as angle 3, which is below the parallel line on the other side of the transversal. So angle 2 and angle 3 are congruent. So notice these are between the parallel lines and these are not between the parallel lines. That's the difference. But they're still equal to each other. So either way, when I go to write my equation, this angle here is going to be equal to this angle here. So I can say 7x minus 16 equals 4x plus 20. Now, if you feel like you can solve that on your own, pause the video, solve it, check back to see if you got it right. I'm going to go through it and do it quickly and then unpause to give you the answer. So pause now. So here's what I got for x. Check your answer, see if it's correct. If you were to put that number back in here, 7 times 12 minus 16, and 4 times 12 plus 20, we should get the same answer, and I believe you get a 68-degree angle. So even though this picture looks like an obtuse angle, remember, it's just a picture so that we can see their alternate exterior angles, not to tell us that it's obtuse. So don't get alarmed if your answer comes out to an obtuse angle when it looks acute, etc. It's just to help us see how they relate to each other. So those are alternate interior and alternate exterior. Let's open up for the inside to talk about some more pairs. Alright, so if we look at this side, we have consecutive interior angles. So the word consecutive means in a row, or one after another. And they're both going to be interior again, so notice we're only looking at angles between the parallel lines. But consecutive means that instead of being on alternate sides of the transversal, they'll be on the same side of the transversal. So I like to also use the phrase same side interior. So I'm going to write that down here. You should also add that onto yours. Same side interior. I'm going to highlight that in a different color so it sticks out. And these are interchangeable, actually. So some worksheets may call them same side interior. Other worksheets may call them consecutive interior. You need to kind of know that they're both the same. So maybe I'll put an or here. Same side or consecutive. So when I'm looking at angle 1, it's not going to be 1 and 4 like alternate interior angles. It's going to be 1 and 3 because they're both on the same side and they're in between the parallel lines. And then for 2, it's going to be 2 and 4. Because again, they're both on the right of the transversal and in between the parallel lines. So when we fill in our description, we have both angles that are between or inside the parallel lines, because that's our interior part. And then we have, instead of opposite sides of the transversal, we're going to say same side of the transversal. And if you notice, this is where I'm going to use what the angles look like, because remember when we did the Notice and Wonder, we had some 60-degree angles and some 120-degree angles. This is an obtuse angle and this is an acute angle, so they are not the same because they're two different types of angles that are created. So these two are not going to be equal to each other. Instead, they're going to add up to something. So if you think if this was the 120 and this was the 60, 120 plus 60 equals 180. These are supplementary angles. So something that helps me remember that when you have consecutive interior or same side interior, if you think of alliteration, we have SSS, so the supplementary, and same side supplementary. So that means angle 1 and angle 3 won't be congruent to each other. Instead, angle 1 plus angle 3 are going to equal 180 degrees. And the same thing is true for angle 2 plus angle 4. That'll also equal 180 degrees. So in here, these equal 180 degrees, and on this side, they equal 180 degrees. That's what supplementary means. So when I look at my example, I have an angle up here and an angle down here. And those are both going to add up to equal 180 degrees. So when I write my equation, it's going to be 5x minus 19 plus 4x plus 10 equals 180. So go ahead and pause your video now and check back for the answer. We're going to explain this one a little bit because it's different from the last one. Notice I don't have x's on different sides of the equal sign. They're both on the same side of the equal sign. So I have to combine my 5x and my 4x together to make 9x. And then I have to combine my negative 19 and my positive 10 together. And that makes negative 9, so I'll put minus 9 equals 180. And then I add 9 to both sides. 9x equals 189. Divide by 9 on both sides. Grab my calculator. 189 divided by 9 is 21, so x equals 21. And if I put 21 in here and 21 in here, I'm going to get different angles, but both of those angles should add up to 180 degrees. So the fourth pair are called before I go on to corresponding. There are consecutive interior angles and consecutive exterior angles. I didn't include an example of that because we know what interior and exterior are now, so I thought now showing you what consecutive means, you should see that the same thing will be true for exterior angles. So if I had an angle up here and an angle down here, like if I look at this example, angle 1 and angle 7 are consecutive exterior, they would add up to equal 180 degrees. Angle 2 and angle 8 would be the same thing. So the last new one is called corresponding angles. And so corresponding, if you think about, you've probably heard the word correspondent before. And like a news correspondent is someone who is like on location. So you might have like a news anchor in the studio, and then they might look for someone on location. And that means like they're doing the same job, but they're in a different location. So this is all about the location of where the angle is. If we look at the diagram, we have two parallel lines. We have this transversal that comes through. Up here, the transversal makes 4 angles, and down here it makes 4 angles also. When the lines are parallel and this transversal comes through, these angles up here are going to match these angles down here. So corresponding angles are going to be one angle from up here and one angle from down there, and they're going to be in the same location on both sets. So what that means is I'm going to have one above or below the parallel lines and one between the parallel lines. So angle 1 is above the parallel lines, angle 5 is between the parallel lines. But if I take these 4 angles and I drop them down here, like imagine picking these up, moving them, and dropping them, angle 1 would land right on top of angle 5 because it's like the top left corner up here. It's also the top left corner of these 4 angles. So I've got one above or below and one in between, and then they're going to be on the same side of the equal sign. So if I'm looking at the angle pairs that I was just talking about, that's this one, angle 1 and angle 5 will match up. So angle 1 will be congruent to angle 5. But there are more pairs here. And notice, acute angle, acute angle. So these have a congruent relationship. They are equal to each other. When the lines are parallel, if I pick up these 4 angles and I bring them down and drop them on top of these, angle 1 is going to match perfectly with angle 5. Angle 2 will land perfectly on angle 6. Angle 3 will land perfectly on angle 7. And then angle 4 will land perfectly on angle 8. So we get 4 pairs of angles that are congruent. Angle 2 will be congruent to angle 6, we said. Angle 3 will be congruent to angle 7. And angle 4 will be congruent to angle 8. So these are 4 different statements. There's kind of a separation here with the commas. So this is a pair, this is a pair, this is a pair, and this is a pair. And they're equal. So when I'm looking at the parallel lines, and I'm looking at which ones they gave me this angle here, and they gave me this angle here. Those are corresponding because they're both, if I'm looking at this intersection, the top right corner, this intersection, top right corner. So since those are both corresponding, they're going to be equal to each other. So my equation will say 10x minus 26 equals 7x plus 40. Pause the video, solve it, and check back. Alright, you should have gotten x equals 22. Check your work, and we're going to move on to the last two pairs. So our last two pairs are pairs that are not unfamiliar to you. You've seen them before. I just want to show them to you on parallel lines. So the first one is vertical angles. We've done vertical angles before. They usually show up where we see an x. So if you look here, we have an x. We have an x at the top, and we have a different x at the bottom. We still have pairs of vertical angles that show up. They are angles that are diagonally across from each other when we see an intersection of two lines. But what's intersecting here, instead of it being an intersection of just two lines, I have this extra line down here. But if I focus on just the top, these two lines are intersecting, the transversal and one of the parallel lines. 2 and 3 are vertical, and 1 and 4 are vertical. Nothing is different. They're still the same thing that we've been talking about. They're still equal to each other. So where are they located? They're located diagonally across the intersection of a transversal and a parallel line and the transversal. So diagonally across the intersection of a parallel line and the transversal. And they share only a vertex. And their measurement is they are congruent, just like we learned before. It's just that now that I'm looking at this diagram with two parallel lines, I have a lot more angles to look at, so I still need to be able to recognize when I have vertical angles. So like we said, angle 2 and angle 3 are vertical. So that's angle 2 is congruent to angle 3. Angle 1 and angle 4 are vertical, so they will be congruent. And you guessed it, angle 5 and angle 8. And then angle 6 and angle 7. So nothing different, just more pairs of vertical lines, more pairs of vertical angles when I'm looking at more lines. And again, these are divided statements here. So if I'm looking at this example, I have a pair of parallel lines, but this top line isn't even important. There's not any angles on it. So it's almost like I can cover that right up, and then it looks exactly like what we know. The angle on this side and the angle on this side, they're across from each other, they're vertical, they're equal to each other. So 12x plus 8 can be equal to 16x minus 32. 16x minus 32 equals 12x plus 8. Solve for x. It doesn't matter which one you put on which side when they're equal. When you're adding them up, it doesn't matter which one you put first. Just make sure you have those, you're copying the signs over correctly. So pause the video, solve for x, and check back. So after I solved it, I got x equals 10. Alright, and then our last pair, also not new. We have a linear pair of angles. We've seen linear pair before. But again, it's in a more complicated diagram. That's the only difference here. So when we're looking at a linear pair, we know a linear pair is a pair of angles that form a straight line, so they form 180 degrees together. They're adjacent angles. So what we have to be careful for here is that we pick two angles that are actually next to each other. We're going to list some examples, but it's not all of the examples. Okay? So they are adjacent angles that are either across a parallel line or are across the transversal. So I'll show you what that means. We'll look at it one way on one line and the other way on the other line. And they share both a side and a vertex. And just like before, a linear pair are supplementary. So what does that mean when I look at this picture? I could have a linear pair of angles. I'm going to highlight a little bit differently this time. Going this way across the transversal, and so these two will be the pair. 1 and 2 would be making 180 degrees. Or I could use the bottom pair this way, 3 and 4. Right? Or they could go across the parallel line and they could go this direction. Let's see if I can do this with my purple one. Or you might have them going this way. 6 and 8 are a linear pair, and 5 and 7 are a linear pair. So that's not all the examples. There are more. 5 and 6 are also a linear pair. 7 and 8 are also a linear pair. 2 and 4 are also a linear pair. 1 and 3 are also a linear pair. So we're only going to list some. So notice it says some examples. It's not all of them. Angle 1 plus angle 2 equals 180. Angle 3 plus angle 4 equals 180. I could fill in angle 1 and angle 3 added up equal 180, or 2 and 4 added up equal 180. Or I could list these examples, 5 and 7, or 6 and 8, or 5 and 6, or 7 and 8. So we listed some of them, not all of them. You got to be able to recognize them, whether they're on the side of the line going up and down, or this side of the line going up and down, or whether they're going side to side, top or bottom. When I look at this example, I have an angle here, and then I have an angle over here. So they are right next to each other, sharing this transversal as their common side. They're both on the same line going this way, so I know they make 180 degrees. So I have a straight line right here, a shared side here. So that makes 180 degrees. So when I write my equation, 3x plus 14 plus 5x minus 34 equals 180. Combine my like terms and isolate my variable. X equals 25. There you have it. So get this glued into your notebook. We will first practice the different examples of the types of angles you might see on parallel lines to make sure you know what kind they are. Then we will practice getting one of the angles and needing to find the other angle. So you're going to look at the two angles they give you, and you're going to try to determine what pair they are, or if they give you one of the degrees, you're trying to find the other degree, so you need to know how they relate to each other. If you notice, there were only two types of relationships we had here. They were either congruent to each other, or they were supplementary to each other. You have to know which one. The front, congruent, congruent. So there are only two types. They can either be congruent to each other, or they can be supplementary to each other. So knowing whether they're linear or linear pair of vertical angles, consecutive or same side, corresponding, alternate, interior or exterior, that's going to tell you whether they're equal to each other or whether they add up to 180 degrees. So glue that in, and then we'll start off with some practice just with the vocab or finding a single angle, and eventually work our way to these types of problems where we solve for x. Thanks for watching.